So there's a problem I've run into more than once. In this way that we work nowadays, is I'm in a hybrid working environment. So some days I'm working in the office, some days I'm at home. And there's been a few times where I've forgotten to check something in and push it before I go to the office because I'm working on an entirely different computer there. So oftentimes it's no big deal. I can just remote into my computer at home, push the changes that I need, and continue working. Well, sometimes my computer's gone to sleep, and I found that it can be extremely difficult if there's someone at the house to persuade them to just go into the room and just press a key on a keyboard to wake the computer up. So I finally have decided to do something about that and make it so that I'm not dependent on another person to do that. Now, I've already known that most of my computers support the Wake on LAN feature, and that's just a feature when your computer receives a certain network packet, it will then at that point just go ahead and wake up, power on. Even if you hadn't, it will wake up if it was asleep. If it were turned off, then it will turn on. And in this video, I'm going to walk through implementing that. Now, just to describe the structure of the Wake on LAN packet, it's very simple. The first 6 bytes are just the value 255, so that's written to a record 6 times. And then after that, the computer's MAC address is written to the record 16 times. And so all of that is just put together in a packet, and when you send that to the computer, when it receives it, it will turn on. Now, this does have to be sent as a broadcast message. The reason being, if the computer's turned off, it might not even have an IP address, so you don't really have a way to directly address it. But if you send it as a network broadcast packet, then it will be able to reach your computer, at least if the network is configured to allow it. And while you could send this on any port, it has to be a UDP message. You can send it on any port. I'll be sending it on port 9 because most routers are configured to allow that to go through. I believe port 9 is used for the echo or ping command, so just to see whether or not a computer is online. So now let me walk you through the writing of the source code. Now, if you want to try this out, one of the things you're going to have to do is make sure that the Wake on LAN feature is turned on in your computer. I can't tell you how to do that other than it's probably somewhere in the BIOS or startup settings. Where this is located can vary significantly from one computer to another. I happen to be using an HP computer, so this is where I navigated to turn it on. It will probably be somewhere radically different on your computer. But find that option and make sure that it is turned on. Because if it's not turned on, then this program is not going to have any effect on your computer when you try to turn it on. I thought about doing this as live coding, but I think that works out better whenever there's some intermediate steps at which, or intermediate states at which this program can be. This is pretty much an all or nothing thing, so my purpose might not be served by live coding, so I'm just kind of speeding through this, and then I'll go back and I'll talk about what's going on here. Okay, let's start by looking in the main function. I'll try and keep the font as large as I can, reasonably keep it while keeping most of a function on screen. So the main function, first thing to point out is I have hard-coded my IP address within here. And just for the sake of getting this to a working state, I've gone ahead and I've done that. Some other things to point out. Now, I'm using the WinSock library for socket access. And before you start calling functions within there, you get to start the WinSock library up and let it know which version that you want to use. Within this if statement, that's what I'm doing. I'm saying that, hey, start up WinSock. I'm going to be using version 2.2, I think is how it's notated. And if all goes well, then I should get a 0 return value. If I get a non-zero return value, I'm not going to be able to send any messages. And so I just print out something to the error stream and I exit from the program. If things do go well, then I send my Wake on LAN message to the marked with the target MAC address. And then after I get done, I clean up these socket resources. So from a high level, that's all this program is doing. But we need to step into this further. So now let's go and examine the send Wake on LAN message to see what it's doing. So here's the definition for the send Wake on LAN. It's not really doing a lot. It does take that MAC address string and it converts it from being a string to a byte array. And we'll take a look at how that works in just a moment. But then it starts to assemble the packet that we have to send. So as I mentioned before, It starts off by putting the value 255, which is hex FF, into this array 6 times. After it's done that, then 16 times, it will add our MAC address bytes to the same array. And once those have all been added to one continuous array, that is a message that gets broadcast. So the other two methods we need to take a look at is how I broke the string down into a byte array, and then we'll take a look at the broadcast of the message. So let's take a look at changing it to a byte array first. In this function, every time I come across a letter, I add it to a string. If I come across either the colon or the hyphen, those are going to be my delimiters for a MAC address. If I come across those and all the other characters that I accumulated, I am ready at that point to convert them from a string to a base 16 number. So I do that, I get the byte value, and it gets added to an array, but then I clean out that string in which I was accumulating these values. And so this repeats until we get to the end of the string. When we get to the end of the string, there is still the very last byte of the MAC address that hasn't been processed. So we also convert it to a byte and add that to the array. And then we just return the entire array. Now let's take a look at what happens when we're trying to broadcast the message. The broadcast message function has all of the serious work within it. I start off by creating a datagram socket, and this is what you'd use in order to send UDP messages. Now I will point out that right now this version of the program is only using IP4. I might come around to it later and use IP version 6, but for my purposes and getting to something that's working as quickly as possible, IP version 4 is good enough. Once I create my socket, I try to turn a broadcast option on it. If that fails, then we're not going to be able to send that packet, so I just once again write something to the error stream and then I exit. If we were successful in setting this up for broadcasts, then I assign it to write to port 9. I have it set to write to this broadcast address, and then that's it. I send the data packet. So if the data packet sends, then the computer should receive it and wake up. And no matter which pathway it goes down, if the socket at least got to a point of being open, I do make sure that I close it before I exit from this method. But once broadcast address has run, then that's it. The program has done its work. If it gets at least this far, it's done all that it can do. So there's nothing for me to do as far as checking to make sure that the computer is turned on, because either it's turned on or it's not turned on. So that's everything as far as how this program works. The source code for this program is available online, although it's a different version. The version that's online has a little bit more error handling, and you can pass arguments to it as far as which computer that it wakes up. Just adding a little note and post here. It's like I woke up early this morning, so I went ahead and I also made a C# version. I've also added both signed and unsigned executables along with their hashes. So if you want to grab it, if you go to the GitHub repository now, you can find both source code there, and you can find the signed and the unsigned executables within here too. So those are available now.